Hi, a very warm welcome to all of you. Let me start with a brief introduction about myself. I've got 6 plus years of experience in IT world. It's been very long since I have been working in big data domains. Right now I'm working with one of the renowned player in big data at their Noida location. I'm also Hot&Work certified Apache Hadoop developer. Let's start this. So in a nutshell, it has two components, HDFS file system and MapReduce. HDFS file system is to store the data. MapReduce is used to process that data. It follows master-slave relationship. For HDFS purpose, it has name node as a master and data nodes as slave. And for MapReduce, it has job tracker as a master and various task tracker as a slave. These name node, job tracker, data node, task tracker, these are daemons. Daemons are nothing but the background processes which are continuously running. As Hadoop has been completely written in Java, so each of the daemon, whether it's master or slave, they will run in its own JVM environment. For HDFS, as we have discussed, name node and data node will come into picture. So as we know, HDFS stores the data, and we know it works on DFS principle, which is distributed file system. So Hadoop talks in terms of blocks only. Suppose you have to store a file of 1 GB on Hadoop file system, so that file will get breakdown into blocks. So that will be decided by your block size. In Hadoop 1.x, default block size is 64 MB. Though you have configuration files where you can modify the default block size, but if you are going with the default block size, so for Hadoop 1.x it's 64 MB. So we are taking an assumption that we are using Hadoop 1.x. If we have to store a file of 1 GB, so that file will break down into 16 blocks. If we divide 1 GB into 64 MB, so that will come out to be 16. So 16 blocks would be there. So name node is the daemon, it's a master daemon which will not store your data. It will only keep the metadata of your data. So in our case, we are storing 1 GB data. Now, since that file gets broken down into 16 blocks, so name node will decide where these 16 blocks will get stored in the cluster. Basically, which blocks will lie in which data node, which blocks will lie in which data node. So that is the responsibility of name node. Name node will have only the information of metadata. It will never store the data. Actual data gets stored on data nodes, and data node will store data in the form of only blocks, and name node will have all the mapping which block is residing at which data node. Data nodes will keep on sending their block reports and heartbeats also. After a certain limit, if name node doesn't get any block status report from data node or any heartbeat, so it will mark that data node as dead node. There is one more important thing in this HDFS architecture. There is a concept of replication, block replication by default, which is 3, which means suppose in our case we have stored 1 GB data that was broken down into 16 blocks. So if you are going with the default replication factor, which is 3, so that means your original copy, which is 1 GB, which gets broken down into 16 blocks, plus 2 copies of that data, 1 GB plus 2 GB. That means if I talk in terms of block, so now your each block will have 2 more copies, one actual block plus 2 extra blocks. So total you will have 3 GB of data in Hadoop environment if you are just storing 1 GB data, and plus overall you will have 16 blocks for one. So that means total there would be 48 blocks which will be stored on different nodes. Data node will never store a same copy on the same node. Suppose block number 1 gets stored in data node 1, the other 2 copies will never be stored on the same node, so that will be stored on the different nodes. This is how this fault tolerant is being taken care in Hadoop. So if one system goes down, since you had maintained that backup, so you won't be losing the data. So if I talk in terms of MapReduce, in MapReduce we have also master slave relationship between job tracker and different task trackers. Job tracker will play the role of master, and task trackers will play the role of slaves. Client submits a job to job tracker. Basically, job tracker will decide which task tracker will perform the task, and job tracker will have all the information: which task tracker is currently running, which task tracker has completed the task, which task tracker is idle, and which is down. If one of the task tracker goes down, so it will assign that task to another task tracker. And through heartbeat, task tracker will communicate with job tracker. Task tracker will also send their status report at various stages to job tracker, and job tracker will have all the information about that job, how much more time it will take to execute the complete job, how much job has been completed. It will have all the information. So this is how MapReduce works. If name node goes down, your cluster will go down. You won't be able to do anything. So this is a single point of failure in Hadoop 1.x. This is higher level architecture of Hadoop. This is the higher level architecture of Hadoop. Thanks for your time. I hope you were able to make something out of this Hadoop architecture.